Hello everyone, welcome to Aviation Engineering YouTube channel. So today also I took a new lesson, it is chapter 22 autopilot, lesson number 6 Autothrust. So maybe this one also very important for you. So this is the 6th lesson. So if you still not watch the lesson series regarding 80 chapter 22 autopilot, please watch these videos by click the link in the description. I put the playlist, so just watch from the first lesson to this lesson, so then you can get an idea. So if you are a newcomer, so I'm Kwiation Engineering. I'm professional aircraft maintenance technician. So in this lesson you can learn about A320 family type training practice lesson. So if you wish to do an A320 family type training, so this is the best choice for you, and you can watch free through the YouTube. And make sure to subscribe Kwiation Engineering YouTube channel, and also share these videos with your friends, relatives, and if anyone who want to learn about aircraft maintenance. And also share these videos with the social media like Facebook, Twitter, and LinkedIn, etc. All right, so no need to waste the time, so let's go to the lesson. Alright, so this is the lesson 80 chapter 22 auto flight system, general lesson number 6 auto thrust. Alright, okay. So in this lesson you will learn in detail the auto thrust principles, right? So the lesson contains a auto thrust loop principle and auto thrust engagement, thrust levers, auto thrust function logic and modes, and alpha flow protection, auto thrust operation in flight, and disconnection. All right, okay. So the first one, auto thrust loop principle. All right, you can say flight mode annunciator over there, the PFT, right? This is the auto thrust push button in flight control unit. All right, so this is the thrust levers. All right, okay. So to perform the auto thrust function, the thrust target computed by the flight management and guidance computer is chosen by the flight control unit. All right, so to perform the auto thrust function, the thrust target, right? The thrust target computed by the flight management and guidance computer. Flight management and guidance computer 1, no? Flight management and guidance computer 2. Computer is chosen by the flight control unit. Okay, you can see the auto flight system control panel. So the each flight control unit processor sends along its own bus, right, the thrust target to the electronic engine controls, right, EEC1 or EEC2 via the engine interface unit, via the EIU1 or EIU2, is mean engine interface unit 1 or engine interface unit 2, right? Okay, this is the flight control unit 1 or flight control unit 2, right? Okay. So the second one, auto thrust engagement. So the engagement of the auto thrust function can be manually or automatic, right? Remember, the engagement of the auto thrust functions can be manually or automatic. So the auto thrust is engaged manually, right, by pressing the auto thrust push button on the flight control unit, right? So it means auto thrust can be engaged manually by pressing the auto thrust push button on the flight control unit. This is the auto thrust push button. Okay, this is the actual auto thrust push button. Thus is inhibited below 100 feet with engine running. Remember it. All right, so if we push this one engage, auto thrust is engaged. All right, okay. And the auto thrust is engaged automatically, right? Auto thrust is engaged automatically when the autopilot or flight director is engaged in takeoff or go around modes, right? In flight, when the alpha flow is detected, this is inhibited below 100 feet radial altitude except during the 15 seconds following the list off. All right, okay. So this is the thrust levers takeoff or go around in this detail, right? All right. To effectively have auto thrust on the engine, right? To effectively have auto thrust on the engine, the engagement of the auto thrust is confirmed by a logic of activation of EEC. Just remember it. All right, EEC is situated in here in the engine. All right, in the right side of the engine. All right. Okay. Now the thrust levers, right? We are talking about the thrust levers. These are the thrust levers. So the thrust levers are manually operated and electrically connected to the EEC. Remember, the thrust levers is the actual way. Thrust levers are manually operated and electrically connected to the EECs, EEC number 1 or EEC number 2. Note that the thrust levers are never move automatically. Remember this one, the thrust levers never move automatically. Each lever has 3 sectors defined by the detent and stops. Okay, all right. So let's talk about the detents. The thrust levers can be moved on a sector which includes specific positions. Okay, so the first one is rear section. This is the rear section, rear area. For idle reverse up to max reverse, right? Here is the idle reverse and this is the max reverse. Okay, you can see the reverse section, right? This is the idle reverse and this is the max reverse. All right, and then the center section. This is the center section. 0 corresponds to an idle thrust. Okay, here is the correspond to an idle thrust, 0 detent, and CL detent correspond to a climb thrust. Okay, corresponds to a climb thrust. Okay, this is the CL detent. It is correspond to the climb thrust. All right. Okay, the next one, forward sector. This is the forward sector. FLX MCT corresponds to the flexible takeoff thrust, okay, or maximum continuous thrust after or engine failure, right? This is the flexible takeoff thrust or maximum continuous thrust. All right, and the next one, takeoff or go around, TO or GA. This is the TO GA correspond to a maximum takeoff or go around thrust. All right, these are the detents, right? All right. Now, the EECs computes the thrust limits, which depends on the position of the thrust levers, right? It means the EEC computes the thrust limits, right? EEC computes the thrust limits, which depend on the positions of the thrust levers, right? Okay, if both thrust levers are in the same detent, both thrust levers are in the same detent, the thrust limit corresponds to this detent. If both levers are not in the same detent, right? It means if this one is another detent and this one is another detent, the thrust limits correspond to the next higher detent. Just remember this one. If both thrust levers are in the same detent, the thrust limits correspond to this detent, right? And if both levers are not in the same detent, the thrust limits corresponds to the next higher detent. Okay, just remember it. The flight management guidance computers select the higher of the EEC1 and EEC2 thrust limits for the thrust target computation. Just remember it. All right. Okay, and now autothrust function logic. Autothrust function logic. So the autothrust function can be engaged or disengaged, right? Autothrust function can be engaged or disengaged. So when it is engaged, it can be active or not active. Remember, the autothrust function can be engaged or disengaged, and when it is engaged, it can be active or not active. So when the autothrust function is disengaged, the thrust levers control the engine, right? When the autothrust is disengaged, then the thrust levers control the engine. On the flight control unit, the autothrust push button light goes off, right? On the flight control unit, autothrust push button light is go off, and the flight mode annunciator is here, displays neither the autothrust engagement status or the autothrust modes. All right, just remember it. And when the autothrust function is engaged, right? In this situation, the autothrust function is engaged. Autothrust is active. Now the autothrust is active if at least one thrust lever is between the CL detent include and the 0 stop included, and at the most one thrust lever is between the FLX MCT detent and the CL detent, and there is no engine flex to mode. All right, so or the alpha flow protection is active independently of the thrust lever position. Remember, alpha flow protection is active independently of the thrust lever position. Note that in case of one engine failure, right? Remember, in case of one engine failure, the autothrust activation zones become between the flex MCT detent instead of CL detain and the zero stop. Remember this one, right? In the case of one engine failure, autothrust activation zones become between the flex or MCT detain instead of CL detain and zero stop. So because the autothrust function is active, the autothrust system controls the engine, and the flight control unit, the autothrust push button light is on. Autothrust push button light is on. The flight mode annunciator displays the autothrust engagement status. You can see the flight mode annunciator displays the autothrust engagement status in autothrust engagement status in white, and the autothrust mode. This is the autothrust mode. All right. And when the autothrust function is engaged and the autothrust is not active, if at least one thrust lever is above the FLX MCT detent, or both thrust levers are above CL detent, or at least one engine is in flex 2 mode with the alpha flow protection not active. Okay, just remember it. Right. Because the autothrust function is not active, right? The autothrust function is not active. The thrust levers control the engine, right? The autothrust function is not active. Because of that, the thrust levers control the engine. As long as a thrust lever is outside the autothrust active area, the autothrust push button light is on. Autothrust push button light is on. The flight mode annunciator displays autothrust engagement status, cyan, and the manual thrust rating. Okay, remember cyan, right? The flight mode announcer display the autothrust engagement status in cyan and the manual thrust rating. All right. And the autothrust functions computes the thrust target according to modes and their related reference parameters. The reference can be a speed or Mach number, right? In this case, the source is either the flight control unit, value chosen by the pilot, or the flight management guidance computer itself. A thrust, in that case, the source are either the EEC. In thrust, in that case, the source are either EECs, which computes the thrust limits when the autothrust is not active, or the flight management guidance computer itself, with in thrust limits always computed by the EECs when the autothrust is active. Okay, just remember it. And the autothrust modes are now the autothrust modes are speed, Mach, thrust, retard, okay, which can be overpassed by the alpha flow protection. Remember, the choice of the mode is automatically made by the flight management guidance computers according to the active autopilot or flight director vertical mode. Remember this one, right? The choice of the mode is automatically made by the flight management guidance computer according to the active autopilot or flight director vertical modes, right? So this choice is based on a simple law, priority to the speed control. All right. Now, when the autopilot with elevators control the aircraft speed, the autothrust has to control the engine by a fixed thrust mode, right? So when the autopilot controls another aircraft parameter, example altitude, the autothrust has to take care of the aircraft speed by variable thrust demand to the engine, example speed or Mach mode, right? So beside these two modes, retard is only available in automatic landing when engine thrust has to be reduced to idle for the flare phase below 40 feet radial altitude. All right. When no vertical mode is engaged, right? When no vertical mode is engaged, the autothrust operates only in speed, Mach modes except, right? So when thrust mode engage automatically in case of alpha flow, and when autothrust being retard, if autopilot is disengages, the autothrust functions remain in retard mode, the aircraft being on ground. Okay. Now the alpha flow protection. So the autothrust function protects against an excessive angle of attack. Right, alpha protection, the autothrust functions protects against an excessive angle of attack. So the alpha flow signal is detected by each flight augmentations computer, right? FAC, right? So the alpha flow signal is detected by the FAC, remember. So in case of excessive angle of attack or avoidance maneuver, the FAC send an order to the flight management guidance computers, which activate the alpha flow protection. All right. So the autothrust automatically engage or states engage active, and the engine thrust become equal to the takeoff go round thrust for any control lever position. All right. So in this situation, the green message alpha flow, right? In green message, you can see alpha flow with an amber flashing box. This the box is flashing, right? Flashing box is displayed on the flight mode annunciator, right? So when the alpha flow detection is no longer present in the flight augmentation computers, the green message takeoff go around lock with an amber flashing box LK for lock is displayed on the flight mode annunciator. You can see, right? So the alpha flow protections can only be cancelled through the disengagement of the autothrust function. Remember, alpha flow can only be cancelled through the disengagement of the autothrust function. So now the autothrust operation in flight. So the aircraft is on ground and ready for takeoff. Neither the autopilot or the autothrust are engaged. The engines are controlled by the thrust levers. Remember. So to take off, the pilot set the thrust levers to the takeoff go around stop or the flex MCT detain if a flexible temperature is selected on a multi-purpose control display unit MCDU. So this engages the autothrust function, but it is not active, right? It just engaged, but it is not active, right? See, it is engaged, but is not active. So at the thrust reduction altitude, a message on the flight mode annunciators indicates to the pilot that he has to set the thrust levers into the CL detain, right? So as soon as the thrust levers are in CL detain, the auto thrust is active. Remember, the thrust reduction altitude, a message on the flight mode annunciator to the pilot that he has to set the thrust levers to the CL detain, right? So as soon as the thrust levers are in the CL detain, then the auto thrust is active. If the thrust lever is set into the climb to MCT or 0 to climb area, a message on the flight mode annunciator warns the pilot to set the thrust levers to the CL detain white LVR CB message if CL to MCT area, amber LVR ASYM message if 0 to CL area. Alright, so the auto thrust remains active, then the thrust levers remains in this position until the approach phase. Okay. Right, so during automatic landing, before touchdown, an auto call-out retard indicates to the pilot that he has to set the thrust levers into the zero stop. So when he does it, the auto thrust disengages. When it comes to zero stop, then the auto thrust is disengages. This allows the automatic activation of ground spoilers if they are in armed condition. All right. So then on ground, the pilot moves the thrust levers onto the reverse sector. Then the pilot have to move the thrust levers to the reverse sector. Right? Then auto thrust is not engaged, right? So now the disconnection. So the beside the normal auto thrust operation, the auto thrust function is disengaged either by pilot action or in case of a system failure. So the autothrust function can be disengaged either pressing at least one of the two red instinctive disconnection push buttons on the side of the thrust levers or by pressing the autothrust push button on the flight control unit. Okay. This is the autothrust instinctive disconnection push button in the thrust levers or pressing the autothrust push button in the flight control unit. So autothrust disengagement can also be due to an external system failure, right? The autothrust disengagement can be happen also due to an external system failure. All right. So when the autothrust function is active, the actual engine thrust does not necessarily correspond to the thrust lever position. Okay. Consequently, it is important to know what happens after an autothrust disconnection. So when the disconnection is made by the instinctive disconnection push button, the thrust immediately adjusted to the thrust lever position. Just remember it. Okay. Alright. So in other cases, after flight control unit push button disconnection or failure, when the thrust lever is detained, the thrust on the corresponding engine is frozen at its value just before the disconnection. It's like memo mode. As soon as thrust lever is moved out the detain if it is not in a detain, the thrust or on the corresponding engine is smoothly adapted to the thrust lever position. Okay. All right, so that is the end of this lesson. I think you got some good knowledge about this lesson. So Autothrust, right? You have got some good knowledge about Autothrust. So please comment below if you didn't get any knowledge about this one. So if you have any questions, please comment below, then I will try to answer as soon as possible. So this is the sixth lesson. So hope you will watch the previous videos also. So if you still not watch these previous videos, go to the comment below, sorry, go to the my description, then I will put my the link in my playlist, so you can watch from the first lesson to this lesson. Then you will have a good idea about Autothrust general lessons series. Okay, that is the end of this lesson. Thank you for participating this lesson, and next lesson I will going to teach, I mean, you will going to learn about the system controls and indicating. So if you still not subscribe to Aviation Engineering YouTube channel, please subscribe and share these videos with your friends, relative, and anyone who want to learn about aircraft maintenance, especially in social media like Facebook, Twitter, or LinkedIn, anywhere. So yeah, that is the end, and see you on next video. Have a good day for all of you.